Now we compute the vector c over 2, and we observe that, well, if c is 20, negative 7, c over 2, let's get the camera back up here where we can see things. Okay, c over 2 is, well, half of the 20, negative 7. That would be 10, negative 7 halves. And of course, we want to have arrows over these to indicate that they're vectors. In a picture, if this is the vector c, then this is the vector c over 2. It's half as long as the vector c. We could verify that, but since each component is half of, each component of star c over 2 is half of each component of c, you can verify that when we calculate the length, it's going to be half as great. The other thing we'll also observe is that basically the slope of this vector is the same as the slope of this vector. That is, the two vectors have exactly the same direction, easily seen in terms of slope. The slope of a line from here to here is negative 7 over 20, and the slope of the line from here to here is negative 7 halves over 10. And negative 7 halves over 10 is equal to negative 7 over 20. You should make sure you understand why. Okay, so c over 2 has half the magnitude but the same direction as c. And another way of seeing that it has the same direction, the direction of any vector is the arctangent of its y component divided by its x component. Any vector in two-dimensional space, a two-dimensional coordinate system, okay? So the arctangent of negative 7 over 20 is the same as the arctangent of negative 7 halves over 10. Why? Because negative 7 halves over 20, negative 7 over 20 is equal to negative 7 halves over 10, as you can easily verify. Okay, so the vectors have the same direction. Now, we want to divide c by its magnitude. What does that mean? You divide c by the magnitude of c. Well, what happens when you divide a vector by its length? Okay, this is a length vector, so we talk about dividing a vector by its length. Okay, this vector has length, as we've seen, 13, have we calculated the length of the c vector? I'm not sure. Yeah, we have. It's 21.1. And where did we calculate that? That was apparently calculated, and I didn't point it out on a previous board. Should have been in a previous video, but it wasn't. But the c vector is 20, negative 7. Its magnitude is easily calculated by the Pythagorean theorem to be the square root of 449, or 21.1. Now, so the c vector has, right here's your vector, it has a magnitude of 21.1. If we divide a vector of, let's say, just length 20, okay, vector of length 20 divided by 20, well, that means we make the vector 1/20th as long. How long is it going to be? It's going to be 1 unit long. So when we divide a vector by its magnitude, we're going to get a vector whose magnitude is 1. So we get, we expect to get a new vector of length 1 having the same direction, because when we divide the vector, well, when we divide it by 2, we got the same ratio of y component to x component, the same angle, same direction. Doesn't matter what we multiply or divide by, as long as it's a positive number, we're going to get the same angle or direction. So that when we divide c by its magnitude, we expect to get a vector of magnitude 1 having the same direction as c. We call that a vector of length 1 a unit vector. So we're going to get a unit vector in the direction of the c vector. Well, again, c then divided by the magnitude of c is the 20, negative 7 vector divided by its magnitude, which is the square root of 449, 21.1, only being an approximation. So the vector we get is the vector with components, and we have an arrow over it because it's a vector, with components 20 over the square root of 449, negative 7 over the square root of 449. We equal that, and et cetera, et cetera. It's going to give us a unit vector. We can approximate this, but this is the exact unit vector. Now, what's the magnitude of C over magnitude of C? The magnitude of this vector that we got here? Well, we're going to use the Pythagorean theorem, and we're going to square this, we're going to square this, and we're going to add them up. So what do we get? If we square 20 over the square root of 449, we get 20 squared, which is 400, over the square root of 449 squared is just 449. And here we're going to get 49 over 449. When we add them up, we get 449 over 449, and that's a square root, so it's a square root of 1, but of course that's just equal to 1, so we can verify that this is a unit vector. So we call C over magnitude of C a unit vector, vector of magnitude 1 in the same direction as our C vector.